Hello, my friends. How are you? Thanks for coming to the party. This isn't a party? I got all dressed up. Oh my gosh, you mean this? Oh, this is just a math party. That's even better. NKinfinity.com. Thanks for coming. Thanks for joining me today when I talk about, what are we at? 6.5. Guys, there's not much time left in the school year. Make sure you guys have subscribed. Make sure you guys check our website. We're going to be putting lots and lots and lots of review material up there for this New York State Common Core test that's going to come at the end of the year. Everybody excited? I know I am. All right, here we go. For the next, I don't know, half an hour, 45 minutes, I will be known as Mr. Krause. Oh, I meant Mr. Key. All right, all we got to do is figure out, we got to match. I hate the matching game. I got to match the function with the equation. Let's see. These two look normal. Wait, this one looks normal too. Wait, that one looks normal too. These four over here look kind of normal. These two look a little weird. I'm going to come back to those. Those look funky over there. I'm going to start with probably the most normal looking one, which is this one. So remember, the normal logarithmic function goes through this point and kind of looks like that, right? So it looks to me like we might have moved over, maybe moved down a little bit here. So we got to find one that's got a plus maybe 1, 2, 3, 4, maybe minus 1. We got anything that's plus 4 and minus 1? Ooh, that's really steep though. Is this really steep? Plus 4 and minus 1. I see a plus 4 and minus 1. Let's see. I guess this could be g of x. Let's go with that. Plus 4 minus 1, g of x. And then this one here, I don't know. Let's see. This one here looks like a normal exponential decay question. So let's see if we can find an exponential decay question. Now, remember, normal exponential decay questions go through this point and have like a 1/2 or a 3/4 or something between 0 and 1 as its leading coefficient. So let's see. But that's not exponential. What do we got here? Let's see here. That's a negative. Do we just go down? What do we do here? Okay, I don't see any exponential functions that look like that. So, all right. I mean, that's a 1/2, but all right. So maybe what this is it's a flip. I think maybe what we did was we flipped this over the line y equals x. So so maybe it's just a reflection. Maybe it's just a reflection of a log function. So maybe it would be just like a log function that moved over to. So maybe it would look like this. So do those look like reflections in the line in the x-axis? Sure. Now, this should be the point that goes through here. So this should be the point. Oh, this should be the point here. This is hard to do. Why don't we take a look and why don't we check our graph? Let's check our graphing calculator. It's kind of hard to do without a graphing calculator. So let's take our graphing calculator. We'll go, no, escape, grow. Oh, there we go. Let's just graph these babies. Let's graph -2 x to the third. So graph -2 e to the x plus 3. X minus 3, and then plus 2. Ah, that's what that one looks like. There we go. That's what that one looks like. So let's see if we can find that one. It's either got to be 1 or 2, it looks like, right? Ah. Well, hold on. Let me go back to Zoom standard because I screwed up the Zoom. Zoom standard. Ah. So it goes through the point 3, 0, and 0, 2. This must be f of x. All right, that makes sense. Over here, this looks like I don't even know what this is. something that moved over 3 units maybe. That could be k of x. This looks like it might be k of x right here. Doesn't it look like it might be k of x? Moved over 3 units. Doesn't k of x move over 3 units? Let's try that. Go tab, up, delete. All right, come on. Delete. And then we're going to go 1/2. I'm just going to do 0.5 log x minus 3. Log, notice I'm not even going to put a base in there, x minus 3. And then plus 1. Ah, look at that. Goes to the 0.30, kind of steep. There it is. Yeah, that's definitely k of x. All right, so we're getting there. We got the first 3, k of x, g of x, and f of x. So let's get rid of those. We don't need those anymore. F of x. I don't know where I went. F of x, g of x, k of x. All right, so how about the negative log that moved right? This is going to move left 2 and down 3. Left 2, down 3. It's got to be this one. Yeah, this one has to be L of x. And this looks like an exponential function that just moved down. Now, I remember all exponential functions have to go through this, and it moved down 4 units, so then it has to be j of x. And let's see, this looks like, oh, see how it's got a negation? It's got a negation, move to the left 2 and down 3, so that's, oh, no, wait, that's not. Oh, wait, yeah, okay, so this is a negation. If this was going like this, yeah, see? It's got to be this one, h of x. All right, and you could verify that with your calculators. In class, I'm hoping that you'll verify that with your calculator. All right, so let's see what we got here. Write the equation. This is all warm up, right? Direction. Oh, okay. Write the equation of the new function and describe the transformation that occurred. So here's n of x. We're just going to take this, plug it in for x. So it's n of negative x plus 3 is equal to 2 times e to the negative x plus 3. All right, so can you tell me what this negative x is going to do? Let's check that out. So we can always investigate using our calculator. Let's go doc B, sorry. And then we'll go, okay, 2, let's go to the original. The original is 2e to the x, 2ex. Just a normal, kind of steep. Well, now we're going to go tab, 2e to the negative x, and then we're going to add 3. So we're certainly moving up 3, plus 3. So instead of going up, oops, sorry, I just messed it up because I was trying to grab that label and get these labels out of the way. Let me change it. Let me put it back to where it was. So plus 3. Oops. So it certainly did coming down instead of going up, and it moved up 3. Let's talk about p of x. We got a 1/2. So 1/2 p of x minus 2 is equal to 1/2 times, let's see what p of x minus 2 is. So that's the natural log of x minus 2 minus 4, which is really equal to 1/2 the natural log of x minus 2 minus 2. So this is going to be, it's got a dilation of a half. I didn't write the last one up. It doesn't matter. Dilation of 1/2. We're going to move to the right 2 and down 2. All right, one last one. So now we've got negative 1/2 of r to the x plus 3. And to that, we're going to add 2 at the end. So it's negative 1/2 of, and we're going to plug this into here. So times negative 2e to the x plus 3 minus 3 plus 2. So this is going to equal, and then to that we're going to subtract 2. So it's equal to negative 1/2. Oh wait, we got to distribute, right? So let me do this in different colors so you can see it. These are tough problems. Negative 1/2 times negative 2 is just 1. E to the x, because these are going to cancel. And then don't forget we got to distribute this over to here, so that makes minus 1 minus 2. So it really is just e to the x minus 3. That's what our new function is. So how does that differ from this? So it's a reflection. It's a dilation because it changed from being a negative 2, well, from being a 2 to being a 1. And it moved because it used to have minus 3. That means it was right 3. Now it moved just back, so it went left 3. And it was up 2, and now it's down 3, so that means down 5. All that crap happened? Oh, that's tough. I think we're going to investigate that one in class using a calculator. So on the graph below, graph the function 2. Now, I said you can use a calculator. I should have put those marks up on the top. Hold on, let me save this, and then I'll come back right back with you. Okay, now I said you could use the calculator on this one, but this one's not really that bad. You should be able to probably do this one in your head, right? We know that all exponential functions go through the point 1, 0. The next point they're going to go through, if you put a 1 in here, what is the next point they're going to go through? Well, 1, and then 2 to the 1 is 2. So the most important point on an exponential graph is, well, you know they're going to go through 0, 1. I should have said the two most. And it's also going to be 1, comma, whatever the base is. That helps you out, because then I can also do the next one, which is 2, 4, and 3, 8, and then 1 1/2, and 1 1/4, and 1 1/8, and I can go on forever and ever and ever and ever. Man, sorry about that, kids. It's so much easier to do on paper. All right, so if g of x, we're going to now talk about g of x. G of x is the same as f of x, but minus 2. Now, we're not. Do we have to graph it? How is the graph of f of x translated to form g of x? Okay, so if we're subtracting on the outside, this is a translation down 2 units. Whatever the units are, it's down 2 units. Now on this one, we've got the f of x. We've got f of x minus 4. We have the x minus 4 inside the parentheses. So how is that translated? That's translated. Now remember, it's opposite. So if this is minus 4, that means it's going right. Ooh, it's a translation. Right 4 units. What I'd like you to try to remember is that all exponential functions go through 0, 1, and 1, and whatever the base is. So I probably should have put 2 points in there. Oh. Write an exponential function in the form of y equals ab to the x. So let's see here. Y equals a times b to the x. Let's see. It goes through the point 0, 7. So if I plug in 7 for y and 0 for x, let's see, that's a times b to the 0. Well, b to the 0 is equal to 1. So this just goes away. So that means 7 is equal to a. So that allowed me to find what a was. Now I got to try to find out what b is. And I got to try to find out what b is. So y equals 7 times b to the x. So now I'm going to use this point. down here. So in for y goes 112. 7 times b to the negative 4. Now we're going to have to remember what we did yesterday. I'm going to divide by 7. Divide by 7. Grab my calculator. Unless you guys know that by hand, right? Divided by 7. Does it go in nicely? It does. 16 times. All right. So be careful with this one just because that's 4 and 16. Don't get all excited. It's 16 is equal to b to the negative 4. Now, I don't like the way this is written, so I'm going to write b to the negative 4 is equal to 16. Excuse me? Oh, yeah. What are we going to do? How do we solve this? Do you remember? It's from a few days ago. Got to remember. All right, so we want to just get rid of this exponent. I should have written this with a little bit more space. We want to get rid of this exponent here, don't we? All right, so I just have to raise it to the reciprocal. The reciprocal is negative 1/4. Negative 1/4. If I multiply those two together, I get 1. So this is b equals, now if you don't know what 16 to the negative 1/4 is, you can always just do this. 16 raised to the negative, control division, 1 over 4. It's a half. So b equals 1/2. So my equation then is y equals 7 times 1/2 to the x. Now you can check that. You can simply check that by plugging those points back in and just verify it. Or graph it. Use the graphing calculator. I could just go like this. Come on, graphing calculator. I can just go to my graphing calculator. Let's go doc B. Go to my graphing calculator and type in y equals 1 divided by 2. Oops, excuse me. Let me do this the right way. Let's try to be fast. 7, control division, 1 over 2. Come on. Raised to the x. There's what it looks like. And then just go to the table, control T. Do you see negative 4, 112? Yep. Do I see 0.7? Yep, there it is. All right, so let's do this one. So y equals a times b to the x. I'm going to plug this one in first. Let me do a different color so that you can differentiate. Negative 4 is equal to a times b to the 0. Remember, b to the 0 is just 1. So now I have a is equal to negative 4. Halfway there. I'm the easy way there. So now I'm going to rewrite this. Do it in a different color. I'm going black. So y equals negative 4 times b to the x. Now I'm going to plug this point in. So negative 36 over 25 equals negative 4 times b to the negative 2. Ooh-wee. All right, so we've got to divide by negative 4. It's kind of annoying, isn't it? Because that would require me to use my calculator. So what I'm going to do is multiply both sides by the reciprocal, negative 1/4. Negative 1/4. And if I do that, I get, if I multiply this, 4 goes into 36 9 times. So I end up with 9 over 25 is equal to b to the negative 2. All right, I'm just going to leave it the way it is right now. I need to get rid of that negative 2. That's really negative 2 over 1. So if I raise it to the reciprocal, negative 1/2. Negative 1/2. These cancel, and I end up with b equals. Now the negative says flip this, right? And the 1/2 says take the square root. So I'm going to flip it. That makes it 25 over 9, and then I take the square root, and I get 5/3. All right, so now my equation is y equals -4 times 5/3 to the x. Nice. All right, we got two more. All right, let's see how we're going to deal with these. These aren't too bad. They're a little crazy. So remember, it's our regular equation, y equals a times b to the x. We're going to plug in that first point. There it goes. In for y goes 3. In for a goes a, nothing. In for b goes b. And in for x goes 1. Well, that's really just 3 equals a times b. That doesn't look good. That looks like 9b. Well, let me just get it. 1 to the 1 is the same as 3. So 3 equals a times b. Maybe that'll help us out later. But that's not as nice as the last ones. The last ones got rid of b, and I was just able to figure out what a is. So these are a little bit trickier. You pick blue, red now. Oh, not red. Let's go purple. No, purple's too close. Orange. So now I'm going to plug in the other point. So 12 equals a times b squared. So in for y goes 12. In for x goes 2. Okay. Well, that's weird. What am I going to do now? What am I going to do now? I think what I'm going to do now is I'm going to use the substitution property. I want to get rid of this a value. So over here, I'm going to solve for a. I'm going to divide by b. I'm going to divide by b. And I'm going to say, okay, a is really equal to 3 over b. According to this equation, a is equal to 3 over b. So I'm going to plug that in for a. So I get 12 equals b squared. And in for a, I'm going to put in 3 over b. Well, if I multiply this out on this side, what I end up with is 12 equals, remember this b is going to cancel with one of those, so that leaves me 3b, divide by 3, and oh, okay, now I get b equals 4. Well, now I can take that and put that back into here and verify, okay, that a must be equal to 3 over b, which is 4. All right, I'm done then. Okay, so my equation is y equals 3 over 4 times b, 4 to the x power. There she is, sister and brother. Not too bad. A little substitution, not too bad. Uh-oh, this one looks a little funky, Cold Medina here. Let's try this, baby. So y equals a times b to the x. In for a goes 10 equals a times b to the -1. All right, I got one equation now. I'm going to talk about that one in a second. Let's talk about this one, though. And plug in this one. So 0.31 equals a times b to the 4. Let's talk about what does b to the -1 actually mean. Doesn't b to the -1 really mean 1 over b? It does. So what I really have here is 10 equals a over b. Now how can I get a all by itself? Because I still want to get rid of a. I'm going to get rid of a by cross multiplying. So I get a is equal to 10b. And that we're going to use to substitute into this equation. So now I've got 0.31 equals 10b times b to the 4th. Okay. So I got to get rid of the 10. So divide by 10, divide by 10, and I get 0.031 equals b to the 5th. All right, well, how do I get rid of the 5th power? The only way to get rid of the 5th power is to raise it to the reciprocal. Well, the reciprocal is 1/5. 1/5. Anybody got any idea? what that's going to be. Let's see. Yeah. I got to go to my calculator. Doc B. 0.031 raised to the controlled division 1 over 5. 0.499. So B is equal to 0.499. Wow. Isn't that really close to a half? So B looks like it really is a half. Now, was it positive or negative? Positive. All right. So B looks like it's 1/2. So here we go. We're good. Oh, we haven't figured out what A is. Plug this back in over here, and then A would be equal to 10 times 1/2. And I get A equals 5. So it looks like my new solid equation is y equals 5 times 1/2 to the x. And again, let me check that. Let me just check that. We said y equals 0.5, nope, 5 times control division 1 over 2 raised to the x. Oops, got the raised to the x. And I'm going to go to the table, Control T. And what were my 2 points over here? Negative 110. Oops, come on, stop. No. Stop. Why does it do this? I don't know why sometimes it does that. Escape. Oh, it's annoying. I don't know why it does that sometimes. There's negative 110. Sorry about that. And 4.31. Well, there's 4. One more up. 0.3125. There it is. We got it. All right, good enough. Good enough, mate. All right, we're almost done. Stop. All right, I think I already filled this in. So, as before, the most important point for, I said for a exponential was, for an exponential, you have the 2 points. You know it's going through 0, 1, and you know it's going through 1 base. Well, for a logarithmic, you know it's going through the point 1, 0, but it's also going through the point, 1, 0. It's also going through the point base 1. Notice they are just inverses of each other. So we're going to be looking for this to help us out. So if I take a look at this function right here, let me take a look. All I'm asking for is what's the domain of g of x? G of x. Well, g of x, of course, is going to stop at 0, not hit 0. And it's going to go forever and ever to positive infinity. The range is going to stop at negative infinity and go up towards positive infinity. Let's take a look at this, h of x. The domain for this one is, again, oh, wait a second. The domain looks like it's got an asymptote right here at 2. So it's going to be 2 comma positive infinity. And the range is negative infinity to positive infinity. But that's only because it had a transformation take place. All right, so now I want to write the equation for j of x. See here? Base of 10, right? What happened to my base? It got multiplied by 5, right? So normally it would go through this point, 10, 1. But now I've got the point 10, 5. Now it's going through this point. So that to me means that this equation is going to be j of x equals 5 log of x. And then all that means is nothing really changed. It didn't go left or right. So my domain is from 0 to positive infinity, and my range is from negative infinity to positive infinity. Take a look. All right, let's see what happens here. I mean, maybe it's in your best interest to actually draw a little picture. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4, 1. Okay. And 1, 2, 3, whatever. And I'll grab it using red. So normally it would go through 1, 0, 10, 1, and it would come really close to that axis and over there. But now what's going on? We went 0, negative 3. So we went left 1 and down 3. So now it's going to look like this. So if I go left 1 and down 3 from that point, shouldn't my equation then be y equals, if I go left, or k of x, sorry, I should be doing k of x. I'll do it up here. K of x equals log, now I said I went left 1, so that should be x plus 1 and down 3. Now if I put this axis back in, sorry about that, then this becomes my new asymptote. Where it normally was x equals 0, now my asymptote moved over to the left one. Now it's x equals negative 1. So I can get really close to negative 1, and I can go on forever and ever to infinity. For range, it's still going to be negative infinity to positive infinity. Nothing's changed there. All right, so just take a look at those. Not a bad problem. All right, we got 2 problems left. Let's see what we got here. The table below shows the number of new stores the Chipotle chain has opened during the years 2016 through 2014. It says, this is really important. Did you see this? Use the x equal 1 to represent the year 2006. So this is really 1. So this is 2, 3, 4, 5, 6, 7, 8, and 9. So let's get those in our calculator. Go to home. We'll go into the calculator mode. We'll go into year and stores. So year and stores. And 1, 2, 3, 4, 5, 6, 7, 8, 9. And let me use my paper here to get these numbers in. That's not the right one. All right. We got 14, 27, 48, 80, 110, 153, 261, 403, and 681. And the directions simply say, write an exponential regression equation. I don't know why I'm not using my pen. Write an exponential regression equation, round all answers to the nearest tenth. So I go to my calculator, go to menu, statistics, stat calculations, exponential regression. Now your independent variable was year and your dependent variable was store. So you just got to be careful where you put those in. Click OK. And this will tell you what the equation is. Don't forget, here's my equation. Y equals a times b to the x. Y equals a times b to the x. And I should write down what a equals. Unrounded, 10.59599. 10.5992. 5992. What's b? B is equal to 1.58625. 1.58625. That should be good enough. I need to round it to the thousands place. So I'm going to write y equals, now thousands place is this digit and this digit. So you got to decide if you're going to keep it or you're going to go up or down with it. So in this one, we're going to go up. So 10.596 parentheses 1.586 to the x. So there's my equation. And don't forget, common mistakes, forgetting the y equals. Don't forget the y equals. And I almost always put that in parentheses. Use your equation to determine which Chipotle will have 2,000 stores. Now that's the number of stores. That's the y value. So we need to plug in 2,000 for y value. So 2,000. Now we're going to be using some stuff we learned yesterday. 10.596, 1.586 to the x. Get the weird thing alone. We're going to divide by this. 10.596. I'm going to divide by 10.596. And I use my calculator for that. of course, 2,000 divided by 10.596 equals that crazy number. So 188,750, 188.750471. Don't round yet. It's not the end. 1876. 876 equals 1.586 to the x. Now, how do I solve an exponential equation? I have an exponential equation. The only way to solve an exponential equation is to turn it into a logarithmic equation. So what I got to do with this sucker is turn it into a log equation. And it's all about that base. So log base 1.586. And now the x and that weird thing switch sides. So of 188.750471876 equals x. Now that I'm going to put in my calculator clearly. So control log 1.586 of, and then I'm going to just do answer because I don't want to have to retype that thing in because I know I'll misplace something or mistype something in there. And I press enter. So x equals 11.362. So x equals 11.362. Now, 1 represented the year 2006. So if 1 represents the year 2006, in order to figure out what year we're in, the year is going to be, I don't know why I'm still in a highlighter. The year is going to be 2006 plus that number. So we're going to just take it and add 2006. And I get 2017.36, so, plus that. So the final answer is 2017. So sometime during the year 2017, I have the wrong answer here. Sometime during the year 2017, we will get there. All right, I'll be right back. Okay, children, we have one question left, but this one is a logarithmic model. So we're going to do logarithmic equations. So we got to go back. As soon as they say we're going to do regression, go back into your calculator, go here, go here. Now remember, if there's any tabs open, always close out, make sure it's all fresh, and you go back in, you only have tab 1.1. And let's see what it says here. Savings account initially has $500. The number of years T that the money must be in the account for grows to a balance of B dollars. Is shown in this accompanied table. So year 0, you get $500. So actually, years is the independent variable. That's like the X. And B is the balance, which is 500. So they try to trick us a little bit here. So I'm going to put years here and balance, because that's really X and Y. Balance. It doesn't like balance. Balance. BAL must be some kind of function the calculator uses. So I'm gonna just look at my paper because these are funky years. So 0, 13.9. Wait. Hold on a second. I might have misread the question. Give me a second. Sorry, children, I actually misread this question. Well, it doesn't really matter. I'm still going to get these numbers in, but actually balance is our independent variable and years is. So they decided just to kind of do this problem backwards. 21.9, 27.7, 32.2, 35.8, 38.9. and 41.6. As soon as I started seeing those years, and I'm like, oh, okay, they're going to say, okay, this is how long you need to have your money in for this to get this. You'll notice that the balances are nice round numbers. That doesn't normally happen, right? So those are going to be our independent variables, and the dependent variables will be the time. Basically, it's what it's saying is, how many years is it going to take before you get 2,500? How many years is it going to take before you get 3,000? How many years is it going to take before you get 3,500? So there it is. All right, so although I got those in backwards, that's okay. I can fix it right here. Menu, statistics, stat calculations, and now we're going to do logarithmic equation. Where is it? Logarithmic regression. There it is. Logarithmic regression. Remember, balance is our x and years is our dependent variable. Click OK. So here's the equation. They give it to you. It's right there. But you got to remember to put the y equals a times b natural log of x. All right? So what's a? -1. So highlight. By the way, if you didn't notice, I was looking down here at the bottom, not really there. -124. So a equals -124.249903. 249903. B is equal to, go down, 19.99286. 19.99286. Make sure I have those numbers right. It's around to the hundredths place. Well, that's kind of weird. So then we're going to write our equation. You'll see why it's weird in a minute. Y equals to the hundredths place. This one goes to 25. So -124.25 plus, if I round this to the hundredths place, it's 19.99. 19.99 ln of x. All right, there's our equation. Round to the hundredths place. I thought the let me go check, because I thought the number next to this thing. No, there it is. Make sure I got my numbers in there right, because it's slightly different, cancel, than the number I got over here. Let me make sure I have my numbers right. 0, 500, 13.9, 1,000. 21.9, 1,500, 27, 32, 35.8, 38.9, and 41.6. Okay, I was just off a little bit on my first graph. Oh, no big deal. I had this as 20, so I had this written down as a 5 here for some reason. Maybe I just got a little dyslexic. So it says, use the regression equation to predict to the nearest tenth of a year, when are we going to have $7,500? Now remember, in this case, that's the year. X going to go in for X. So this one's not too bad. I just want to figure out in what year. So I'm going to say Y is equal to -124.25 plus 19.99 times the natural log of 7,500. All right, not a problem. Go to my calculator. Big numbers, who cares? Calculator does all the work for us. So -124.25 plus 19.99 times the natural log of 7,500. Oops, one too many zeros. And I get 54.11 years. So Y equals 54.11 years. What does it round to? Nearest tenth of a year. So Y equals 54.1 years. There it is, kids. So it'll take a little over 54 years to have $7,500. That's quite a lot of time. Oh my gosh, that's about as long as a math class. Just kidding. All right, kids. Catch you on the flip side. It's been fun. Hit the subscribe button. Hit the like button. Give me a thumbs up. Give me a comment or two if you want. Sorry, I was a little distracted. I got a couple emails from my lifeguards. They got me a little mad, but that's okay. I'll come back. I'll recover on the next one. Goodbye, kids.